Okay, let's look at this lesson 1.7 on creating and solving our multi-step linear equations and with the modeling. I wrote down all of our steps for you already. But looking at number 1, if this is now on there, I already drew the model for you. It's on your notes. But now I need to solve it on the model. So for step 1, it says check for 0 pairs to eliminate on each side, which means you have to look at the left. Are there any 0 pairs? No, I don't see any. And then look at the right. Are there any 0 pairs? I don't see any. If there were, I would get rid of them. I'd eliminate them. Now we're going to go on to step 2. Step 2 now says I need to eliminate. That means I'm going to cross off any tiles that are exactly the same on both sides. Just like when we did that scale with our rocks and our crates. So I can see I can get rid of 1, 2, 3 over here, and 1, 2, 3 over here. They're exactly the same. I also see some units that are exactly the same. I can get rid of these 2 units, and I can get rid of these 2 units. Then going over to step 3. Next thing I'm going to look at is to create any 0 pairs needed to eliminate so I can get all the x's completely by itself. Well, right now I have x's over here and I only have units over here, and that's what I want. I want only the x's on one side, units on the other, so I don't need to create any 0 pairs to get rid of any other units on my left side. So I need to go ahead and start to group my, group them into evenly distributed groups. So if I have 1x here and I have 1x here, that's 2 groups. I'm going over to the right side and I need to break these units into 2 equal groups. So you can see there's one group, there's the second group, and now I can eliminate 1x and 1 group to come up with 1x is going to be equal to 5 units. That's how you're going to solve on a model. We're going to do another one in a minute. When it says solving actions, that means I need to see every single step. You can't skip anything. I need to see the simplification, the inverse operations. So step 1 says distributive property in CLT. There is no need for distributive property or combining like terms. I do need to go ahead and do step 2 where I can see I have variables on both sides. So we always get rid of the smallest amount of variables. So I've got 5x on the left, 3x on the right. So I'm going to get rid of that 3x by subtracting 3x on both sides. And now I'm going to go ahead and simplify. When I simplify, that creates a 0 pair, and I'm left with 2x plus 2 equals 12. Now we're going to go ahead and isolate the variable by doing the inverse operation of that 2. So I'm going to subtract that 2 on both sides. Again, show your simplification. That's what the solving actions are. So I can see that this is going to cross out, and I'm left with 2x equals 10. And now I can continue to isolate the variable of the coefficient. And when I finish all of that, I should have x is equal to 5. So you can see that from a model and from an equation, I will still get the same answer. Now to verify, that means I actually need to see you rewrite that problem where it comes down and I'm putting those parentheses instead of my variable. And now we're going to go ahead and substitute in my answer, my solution, into the original equation. And now showing all my steps for simplification in order to verify. Order of operations, that becomes 10 plus 2 equals 15 plus 12. And then 12, oops, what did I say? 10. Thank you very much. I just had to think about that for 2 seconds. How about 25 plus 2 equals 15 plus 12, which will then give me, of course, my 27 is equal to 27. And does 27 equal 27? You put a check mark to show that you have verified the solution. Now let's go down to number 2. Model and solve. That means I don't want to see your solving actions. I actually want to see you draw the model, which I did. So I started you off there. And now we're going to go back up like number 1 and check for those 0 pairs. Well, there's no 0 pairs on the left. There's no 0 pairs on the right, so I skip step 1. Eliminate any tiles that are on the same on both sides. Well, I can get rid of these 2, and I can get rid of these 2. They're exactly the same on both sides, so I can pick those up. And then I can go to my units. 1, 2, 3. Get rid of 3 on this side. And now when I look at my solution here, I only have 1 x left. And the units that I have left over here would be my answer. X is going to be equal to 4. Now for number 3, you can see I've done the solving action. It says you can use tiles if you want. So number 1, I've done all my solving actions. You can see what the answer is and how I did that. You should be able to do that on your own. But for B, I want to go ahead and look at that as if we were going ahead and getting rid of our denominators. We're clearing those denominators first. So LCM of those 2 denominators is 15. So I'm going to multiply both sides by 15. Now I can go ahead and cancel out my denominators. 3 goes into 15 5 times, and 5 goes into 15 3 times. Now using that distributive property, I'll get 5x minus 15 is equal to distributive property 6x plus 12. Now here again, I've got my variables on both sides, so we're going to get rid of our smallest variable, which is 5x. So I'm going to subtract 5x on both sides. I'm going to show my simplification. So I'm going to get rid of that. That's a 0 pair. Negative 15 is equal to x plus 12. And now, isolating that variable by getting rid of that constant, subtracting it on both sides. And then, of course, you can see when we do that, I get negative 27 equals x. So those again are how we would go ahead and solve using our solving actions. And hopefully that makes sense because we're going to be using those models again later. If you have any questions, you can go ahead and email me, but we will talk about this in class. Have a good one. Thank you for listening.